Oh, I just realized I was on mute. Um, Angelo, we'll go ahead and start with you for number 16.
So for 16, I factored out the 5 first.
Okay.
So then I'm left with n squared plus 2n plus 4.
Alrighty, good.
And then I factor down the n squared plus 2n plus 4, which is n plus 2 with outside and n plus 2.
Alrighty, yeah, because that's a perfect square trinomial. 2 times 2. Hold on a second. You said n plus 2
Just
and
n plus 2.
just n plus 2?
And,
One of them?
no, I did 2 of them. The n plus 2 and plus 2, I believe.
Because if you multiply and FOIL these two parentheses, your middle term will end
Oh,
up.
wait, it's supposed. It should just be 5n squared plus 2n plus 4.
Yeah, you will not be able to factor it any further.
Wait a minute, I went too far. I went too far with the factoring there. I was like, that's not right.
Yeah, because if you multiply back, you would not come back to that parentheses portion.
No,
So this part here cannot be factored anymore. Did the rest of you guys in that breakout room 1 have the same result? Did anybody have a different answer?
That was what I got.
That was what you got, okay. And the remaining of you did too? Yeah, Braden, Maya, Jack. Okay, alrighty, very nice. So that will bring us to breakout room 2, since you guys were doing the odd numbered one. So for 17, how about Anna?
So for 17, I got 2 parentheses k squared plus 11k plus 30.
Okay.
And then I got 2 parentheses k plus 5. And then parentheses k plus 6.
All right, yeah, very nice, because 5 times 6 will give us 30, and then adding 5 and 6, of course, gives us 11. All right, good job, Anna. And then you guys in room 2, did everybody have that answer? Did anybody have a different answer than that one?
I did.
I just put the 2 in with the k plus 5. So I had 2k plus 10 and then k plus 6.
Oh, k plus 10. But then that would have multiplied. Oh, so you did not bring the 2 out, Katie? Is that what you did?
Yeah, I just kept the 2 in with the k plus 5. So I had 2k plus 5. Or 2k plus 10.
Yeah, so then if you actually from the 2k plus 10, if you just like take 2 outside, you would end up with k plus 5 just inside the parentheses, and you still had the k plus 6. All righty, very nice. So that brings us to number 18, and let's see, how about Arthur from the first group?
So number 18, I got parenthesis a minus 10, close parentheses, and then parenthesis a plus 9, close parentheses.
Yeah, because in this one, since that 90 has a negative sign, we know we should have 2 opposite signs in our parentheses. So again, negative 10 multiplied with 9 will give us negative 90. Negative 10 added will 9 will give us negative 1, which will be that middle term. All right, great job, Arthur. Very nice. Did anybody have questions on that one? Okay. Let's see, number 19. And this would be room 2. So how about Brandy?
All right, I factored the 11 and the 10, and I said 10 plus 1 would be 11, and 10 times 1 would be 10. So P plus 10 and P plus 1.
All righty, P plus 10 and P plus 1. Yeah, when you multiply 10 and 1, of course it's 10. Adding 10 and 1 will give you 11. And that's the only combination that would work out, because, 5 and 2 would not add up to 11. Very nice, Brandy. All righty, very good. So that will bring us to number 20, which would be, how about Braden?
For 20, I got 5 times v minus 2 and v minus 4.
Okay, so let's see, we're taking the 5 outside, which would leave us with v squared. 5 goes into 36 times, and then of course 5 goes into 48 times. So -2 times -4 would give us +8. And then when we add -2 with -4, we would get -6. All right, very nice, Braden. Good job. Okay, again, did anybody else have questions on 20? Or were we okay with that one? We're okay? Alrighty, so that was Braden. Okay, so that will bring us down to number 21 then. And for 21, how about Jackie? What did you have?
I got 2 parentheses p -1 and then p plus 2.
Right, and this is the question that Brandy had asked me about. So Brandy, were you able to fix that, or were you still kind of struggling with it?
No, I fixed it.
You fixed it, okay. Yeah, so what's happening here is since we're taking the 2 outside, you know, that's leaving us behind with p squared plus p minus 2. So when we multiply -1 and +2, we of course get -1, and adding them will end up giving us +1 for that middle term. So very nice, Jackie, nicely done. So let's see, where does that bring us back to number 22? And number 22, Jack, what did you have on that?
So for number 22, I got 4 parentheses v squared minus v minus 2, which becomes 4 parentheses v minus 1 parentheses v plus 2.
Okay, v minus 1 and v plus 2, okay. Let's see, you took the 4 outside, so yeah, that left you with v squared minus v minus 2. So when we multiply -1 and +2, we get -2. But what's happening here, Jack, is then when we add -1 with +2, you're actually going to get +1 and not -1 for that middle term.
Oh, yeah. Shoot.
So how would you change that?
So I would multiply -2 and +1. So it'd be v plus 1, v minus 2.
Very nice. Yeah, so just switch the signs on those numbers. So v plus 1, and then this guy should be -2, and that would work. Alrighty, very nice. Good job. Okay, so that was 22. Let's see, 23 would be again room 2. So Katie, what did you do on that one?
I got x minus 5 and then x minus 10.
X minus 5, and you said x minus 10. So when we multiply the two numbers, we get +50. That's good. And adding them gives us -15. All right, very nice. Good job. Let's see. If you don't have any questions, if you do, just let me know. For 24, how about Maya from group 1?
I got parentheses v minus 5 and then parentheses v minus 2.
Okay, so let's see. When we multiply -5 and -2, that's +10. And when you add them, it's -7. All right, very nice, Maya. Nicely done. So that brings us to the last 2 problems on this handout. So let's see for number 25. Mikhail, what did you do for that one?
For number 25, I got p plus 3, then p minus 6.
P plus 3, p minus 6. So again, since you have a negative sign on 18, you should have 1 positive, 1 negative factor. So when we multiply +3, -6, we get -18. But Again, if we add positive 3 with negative 6, you would actually get negative 3 and not positive 3. So how would we change that?
I don't really know how I did that. I meant to I meant to have the 6 be positive and the 3 be negative, but I didn't write that down when I was doing the problem.
Okay, yeah, so when we do negative, because you know, you're still gonna get negative 18 because one of the signs is negative, but when we add them, the negative 3 and the positive 6 is what's gonna give us positive 3. So yeah, sometimes it can be just a matter of, you know, changing our signs and getting the right answer. All right, very good. So I think I've actually asked each one of you from each group. So that leaves us with 26. And for 26, I'll leave it open to group 1. Any of you can tell me what you guys did for number 26. What did you do to factor it out?
So I figured out the 6 first.
Okay.
It leaves you with b squared plus 11b plus 10.
Okay.
And then you can factor that down to 6 on the outside with b plus 1 and b plus 10.
Alrighty.
Or
So
basically, yeah, you already put it down.
okay, so yeah, keeping both of them positives, 6 on the outside, and 10 times 1 would be 10. 10 plus 1 would be 11. All right, very nice, Angelo. Good job.
Thank you.
All righty. Did anybody have questions? And even if you were in the other breakout room, did you have any questions on the ones you did not work on? So are you feeling comfortable with at least this first part of factoring? Yeah? Okay, so I'm about to confuse you if you're feeling comfortable. So our next set of handout, and let me send that to you here through chat. Come on, buddy. There we go. All right, so for my second, and this is where we are now actually changing our coefficient from just being 1 to a number which could be greater than 1. But you know, the difference that's going to happen is we may not be able to factor it out. So if you look at that handout, it's going to be this one over here, a greater than 1. So as you can see with this very first example, you know, we are not able to bring that 3 outside as our greatest common factor because, you know, 3 of course would not go evenly into 2 or 5. So this is kind of where, you know, again, you can use trial and error to help you out, or you can kind of do it more in an algebraic sense. So let me again just show you how we would break this guy down. So this is number 1. We've got 3p squared minus 2p minus 5. So trial and error method would be, you know, where we break down that 3, basically the number 3 into 3 times 1. We break down the negative 5 into either negative 1 and positive 5 or positive 1 and negative 5. So that means 3 times 1 would be 3p and just p for the 2 parentheses. And then we would have to see, is it negative 1 positive 5 or, oops, or is it going to be 3p positive 1 and p minus 5? So you would kind of have to check and see which one of these, you know, of course, would end up giving us the correct answer. So the best way to check for these trial and error method is go ahead and multiply the middle 2 terms, which would end up giving us negative p, and multiply the last 2 terms, which would end up giving us, what would that be? 15p. And when we add them together, we get what? 14p, right? Which is definitely not our middle term. So we know this combination does not work out. If you try and do that over here, you will see again, this one will give us positive p. This one, when we multiply 3p with negative 5, we get negative 15p, which will come out to be negative 14p, which is again not our middle term. So those two combinations don't work. So then what we would have to do is actually switch the places of 1 and 5. So you can do 3p plus 5, p minus 1, or we would have to do 3p minus 5 and then p plus 1, and then you would have to see which one of these combinations would work out. So multiplying these guys together gives us 5p. Multiplying these guys together will give us negative 3p. When we add them together, that's a positive 2p. And of course, again, we're looking for negative 2p. So this guy is gone. So obviously, this is our last hope over here. So negative 5p, positive 3p, and let's see, when you add them, you get negative 2p, which was our middle term. So that's the combination that works out. So that's basically the trial and error method, where you keep switching either the signs or the actual position of the numbers and then see which combination is going to work out. And you know, some of these, I think if you have practiced enough, some of these you can kind of see, okay, I know if I put the 1 with the 3p, it's not going to work. So I should have the 5, you know, combined with 3p. So that can be something, you know, you can acquire with practice. The other method, which is kind of what I normally use because I'm too lazy to do trial and error to keep trying different combinations. So, you know, our given trinomial was 3p squared minus 2p minus 5. So what I actually do is take the leading coefficient, multiply it with the constant term. So 3 times negative 5 is negative 15. And then you are looking for factors of negative 15, which would add up to give us negative 2. So you have negative 5, positive 3, positive 5, negative 3. And you know, of course, we have 15 times 1 with positive or negative signs. But you can see only one combination will work. And that's going to be the first one, where you have a negative 5 and a positive 3. And then, you know, once you figure that combination out, and this is kind of what I believe Mikhail had started us off with when we had done that first handout, you know, the one we just finished working on. So you split your middle term by using these two numbers. So we're going to split our middle term into negative 5p and positive 3p. You're going to bring down the negative 5 as it is and the 3p squared as it is. So your expression will become 3p squared minus 5p plus 3p minus 5. So we've literally just split our middle term, and then you factor by grouping. So we group the first two terms, we group the last two terms, find out what's common, you know, bring it outside. So between 3 and 5, nothing is common, but we do have p squared and p with the, you know, 1p, which will be common. So that leaves us behind with 3p from that first term and then minus 5 from the second term. You've got a plus in the middle. And if you look at the second set of parentheses, you know, of course, between 3p and 5, nothing is common. So you can always bring 1 outside when nothing is common as your greatest common factor, which will leave us behind with 3p minus 5. And I always say this, if we do this correctly, our two parentheses should always come out to be the same. So you don't have to make them be the same. They automatically come out to be the same. And when that happens, combine them into one single set of parentheses. And then the p and the plus 1 becomes the second set of parentheses. So the common ones will become one pair. And then the p plus 1 from the outside will become the second pair. And you will notice this was the same combination we had over here, 3p minus 5, p plus 1. So that's the algebraic way of doing it, you know, where you multiply the leading coefficient with the constant term, you get your negative 15, split up negative 15 till you can get that middle term of negative 2. And then using that, we use factor by grouping to come up with our answer. Or you have the trial and error method that I showed you here at the beginning. And I'm okay with whichever method you want to use, because ultimately you have to be comfortable with the factoring. So, you know, go with what you are comfortable with, maybe what you have used in the past. So let's go back over here. So as you can see, this guy factored into 3p. I think that was minus 5. Yeah. 3p minus 5 and then p plus 1. And you will notice that in a lot of these other examples, again, look at number 2. This 2 is not going to be common between 3 and 9, so we won't be able to bring it outside. So again, try factoring that and let me see what answer you come up with. And for this one, what I want you guys to do is get your answers ready and then, you know, send it to me to chat. So I would like to see, you know, if all of you are able to come up with answers on your own. So just have your answer ready, and when I ask you to, you can send it in. So I'll give you a few minutes to work on it. And you know what I would like you to do is when you type your answer in, at the end, just put a T at the end to let me know if you're using the trial and error method. If you're using the algebraic method, then don't put the T. But if you use the trial and error method where you're trying the different combinations, then just put a T. So I kind of get an idea of which method is, you know, your preferred method. I'll give you just another minute and then I'll have you send the answer. So don't send them just yet. Okay. Go ahead and send your answers in, guys. So I have, let's see, Brandy, you've got n plus 3, 2n minus 3, 2n minus 3, n plus 3, 2n minus 3. So none of you use the trial and error method? Okay, so 2n minus 3 and n plus 3. All right, so let's take a look at that. So, of course, when I think about multiplying 2n with n, we know that's going to give us 2n squared. So that would be the first term. When I multiply the negative 3 with the positive 3, of course, we're getting negative 9. So that takes care of the last term. So far, so good. Then to check for the middle term, again, just multiply the negative 3n and multiply the 2n with positive 3, which would be positive 6n. When I add them together, I get a positive 3n, which is what you have in the middle term. So yeah, very nice. Good job, guys. That's definitely the right combination for factoring these out. I wanted to point one thing out. If you look at number 8 down here, it's giving you 9k squared plus 66k plus 21. Now, this example is actually pretty interesting because it looks like, okay, there might be nothing common between the 9, the 66, and the 21. But if you actually take each of these numbers down, you can break that down into 3 times 3. 21 can break down into 7 times 3. Now, 66 has many different combinations, but I am seeing a number 3 being common between the first and the last one. So you can actually take 3 as a common factor out from that 66. So even though it may not seem obvious, you can actually take that 3 outside as a greatest common factor, and then you can simplify it. So some of these examples will have that option of bringing out a greatest common factor and then trying to simplify it. But then, some of these are going to be pretty obvious, like the ones we were looking at, where you're not going to have anything in common that you can bring outside. All right, guys, we will pick this up next time. So we've got a total of, I think, 18 problems in here. And again, I would like to, again, use breakout rooms to try and get you guys working a little bit in groups so you can help each other out. So we'll do that for our next class, which would be on Monday. So again, please remember, I have changed the due dates for the Math 121 course deadline. So you now have September 30th as the exam date instead of the 28th. So that should give us one more day to finish talking about 2.4, 2.5, and then getting ready for the exam. Do you have any questions before I let you guys go? Everybody doing okay? All right, everyone, have a wonderful weekend, and I will see you on Monday morning. Take care, everyone. Bye-bye.
Have a good day.
Thank you. Bye, guys. I'll see you this afternoon, okay? Bye.